Hi everyone, my name is Kimberly Huaringa, and the topic that I'll be talking to you about today is the preparation of a Z-idoalkene through stroke-Zhao-Witting all definition, if I'm saying that correctly, stereo retentive lithium ion extension. So we're going to talk about the scale and optimization. The first and second runs of the experiments were carried out on the same scale. The experiment was not carried out on a greater scale. That being stated, the experiment was conducted on the safest scale indicated in this experiment. The experiment was not costly and it could be done in the lab, but it cannot be done at the same time because of the dry ice acetone, which could be expensive to keep in the lab due to the cost and how everything, depending on the school, technically, if we were able to have that in the lab. The check-in process is the experiment benefited from the checker's contribution. In step 11 in the notes was dominated by the checkers. So the checkers did a second run on an identical scale that provided the 13.55 grams of the product, which was 72%. So what the checkers technically did was that during the second run, they wanted to see if they would kind of estimate to finding if they got something similar to both the percentage in the lab. So the reaction apparatus, which is one, the size and type of flask, which was a 10 milligrams of third neck, which is a NS29, NS14, and NS14 again, which they used that during the lab, which is a round bottle flask with a 40 mm egg shaped and then for the second part, which was the equipped in, which is the flask is removed from the oven, equipped it with the NS29 glass topper, a glass gas adapter with an argon inlet, which is the NS14, and 100 milligrams pressure, equalizing the additional funnel, which is also the NS14, that's dried overnight in the oven. It was topped with the same NS14 glass stopper and the argon in which is connected to the shingling line, if I'm saying that correctly. Um, the next one is the reagents and starting materials. So we have the mass, the volume, the all of them here listed in our chart, which is talking about the idomethyl triphenylphosphanum iodine, if I'm saying that correctly, and then the tetrahydrofuran, which is also with the THF, and also the last one, which is the NaHMDS, which is also added with the THF in here. So we found all of this in the articles, which is the mass, the volumes, the equivalency of all of this that we have. And also, we do have two of them, which is the first one and the last one. The equivalency are the same. And towards later on, we'll talk about more about the equivalency and how it differentiates or how it's the same. So the reagents and starting materials is that any specific precautions of the reagents required, which was like there was no specific precautions. The proper PPE, which is a personal protective equipment such as goggles, gloves, and lab coats, are still important to wear during the course of the experiment. What are the limiting and excessive reagents? As the reagents are equivalent, the limiting reagent is not promoted to this because, like I said in the chart before, both reagents equivalency are 1.2 m in the experiments. So the reaction procedure. So first we go when under decreased pressure, the setup was allowed to cool to room temperature. And after it reaches the room temperature, the shingling line is converted to argon flow. The setup is kept as a small positive argon pressure, and appearance was forming a cloudy off-white substance, which shows in picture 1 here the appearance of the suspension after. What once it was the idomethyl triphenylphosphanum iodine added and stirred. And then the second one is the appearance of the suspension, after the NHMDS addition has been completed. And then the fourth one is the reaction flask is then placed in a Dewar's vessel and cool for negative 75 Celsius using a dry ice acetone mixture. This process takes about 15 minutes. The clear, deep red solution is stirred at negative 75 until the complications of the reactions, which requires an hour and 1.5 hours of it, an hour and a half technically. The dry ice acetone bath is removed and the reaction mixture is allowed to warm to an ambient temperature. At 30 Celsius, resulting in the crude product as a various brown oil that is seen in the experiments. The aldehyde solution is added dropwise to the reaction flask vial to the addition funnel over an hour with close monitoring, keeping an eye on the temperature that doesn't rise above negative 75 Celsius. And a 25 ml glass tight string is used to charge the 100 milligrams additional funnel with NHMDS. And the same, the NHMDS solution is in THF is added dropwise to the white substation through the dropping funnel over 10 minutes at 21 Celsius, resulting in a clear red solution that transforms into true dark crimson solution over 5 minutes. During the additions, nothing was being noticed. THF is applied to the walls of the additional funnels 3 times using a 50 ml glass tight syringe. The reaction flask is then put into a door jar and chilled with a dry ice acetone mixture to negative 75 Celsius. It also takes 15 minutes. A solution of p-methanol benzaldehyde in THF is added to the washed 100 milligrams additional funnel. Throughout 1 hour, the aldehyde solution is added dropwise to the reaction flask vial to the additional funnel with restricted monitoring to enhance that the internal temperature doesn't exceed to negative 75 Celsius. The sides of preparating for the funnels are then washed with THF, which is added to the reaction flask dropwise over 5 minutes. The additional funnel is replaced with the NH14 rubber spectrum to make adequate removal possible. The clear, deep creaminess solution is adjusted to like negative 75 Celsius for an hour and a half until the reaction is complete. When the reaction is finished, an adequate stereo solution of NH4Cl, which is 150 milligrams, is added to a single amount using a 250 ml graduated cylinder. The reaction mixture is allowed to warm temperature once the dry ice bath is removed. The contents of the flask are diluted with N-pentanol. I'm sorry, not pentanol. With N-pentan, 150 milligrams, and suction filtered into 1,000 milligrams. Flask using a saline pan, which is 3 centimeters deep, the top of the 10 centimeters diameter of the funnel. Um, Diethyl ether, which is used to rinse the reaction flask and flush to the saline pad. The mixture is results in put into a one separate like funnel. The organic layer is separated from the craticus layer, which is extracted using the diethyl. The mixture organic extracts are dried with MgSO4, filtered into a 2L single neck rounded bottom flask through a 10 centimeters diameter cylinder funnel. The round bottom flask covered with aluminum foil is placed on a water evaporator and the solvent is removed at 25 to 35 mHg at 30 Celsius, resulting in a crude product as a various brown oil substance in the flask that we see. Here we have a picture of like TLC and how the MNR spectrums are used to monitor the reaction every 30 minutes. The TLC is carried out on aluminum backed silk gel plates, dissolving in 50% of diethyl and within the observations of the UVA and stain with what we see here are two different stains. The chemical Z-idol olefin, if I'm saying that correctly. One has like an RF of zero point 0.6 and stains of purple that we see in the picture. For 1 hour, not 1 hour, I'm sorry, for like the NMR spectrum of zero point 0.1 ml, proportions are extracted with the needle and syringe and extracted into a vial that includes a 1 milligrams of CDCl3 and 1 milligram, so adequate to the saturated NHCO3 solution. After fully examining and mixing the layers, the CAC layer gets gathered and transported into an NMR tube. So the reaction workup that we have here is the tetrahydrophone, which is a 250 milligrams, is transferred into the flask by the cannula, then stirred, is indentated, forming a cloudy off-white substance that we see in the flask. 100 ml additional fluid is charged with NHMDS. The NHMDS in THF is added to the white substance through the dropping funnel in the dropwise manner over 10 minutes at 21 Celsius, which results in a clear red solution that transfers into a dual dark red solution over 5 minutes. Flask was placed in the dewar vessel and cooled to 75 Celsius while using a dry ice mixture, which takes about 15 minutes. Clear, deep red solution is stirred at negative 75 Celsius until the complications of the reactions, and once dry ice acetone is removed, then the reaction mixture has to warm up. The combined organic extracts are dry with MgSO4 and filtered through a 10 centimeters diameter funnel into a two single-necked rounded bottom flask. The rounded bottom flask, covered with aluminum foil, is placed on a rod evaporator, and the solvent is removed at 250 to 35 at 300. Not 300. I'm so sorry. 30 Celsius, resulting in the crude product as the various brown oil that we see towards the end. So the purifications is the filtration, which is the flask are diluted with and penton 150 ml, and it's filtered by suctioning the filtration through a pan that has 3 centimeters deep on a 10 centimeters diameter insert funnel into a 100 ml aerolinear flask. The chromographics purifications is in a 70 ml diameter column, which is 240 grams of merc 60 silic gel is used to column the chromographic. And first distillation with 100% and pentane, pentane, if I'm saying that correct, 500 ml used. No products must be discarded. After this point, 50 ml fractions are collected by dissolving with 100% and of 25 milligrams, which is 1% of diethyl ether, and lastly about like 2% of that same one, which is a total of 50 fractions. So the fractions for 2 to 48 yields to uh, as a result is the product mixture with fractions containing the solvent, and the solvent is removed from the rotating evaporation that's conducted in the lab. So for the characterizations and proof of purity, we have here two MNR pictures showing the difference of the NMR, which is the one in the left, which talks about the ppm, which is here that we have, which is 3.38, and then on the right side, which is the highest one, which is around in between the middle of like 113.66 to 137.94, but it varies in the NMR spectrum for both of them, which is what we were conducting in the experiment. So safety notes and hazard warnings. All chemical waste should be disposed of in a location that is for all regulations that we need in the lab. Like liquids should be in certain, distribute and dispose in a specific, jar. Also the solids that we use as well. And chemical specific dangers are underlined in red cautious remarks inside process in various organic synthesis articles. It is critical to understand that the lack of cautious note does not suggest that there's no serious risks. The chemicals used in such operations pose dangers. A complete risk evaluation must be conducted prior to initiating a reaction, which involves a concentration of the possible dangers related with each chemical and experiment produced. Um, on the scale that is anticipated for the process. We definitely, in the lab, for safety precautions, we have to wear goggles, we have to use gloves, also use a lab coat, also follow all these regulations that we need in the lab that our instructor provides us to do always in the beginning of the lab, and always to be safe for everything that we're doing in the lab. For my discussion sections, so this is my mechanism that I have. So it shows the process of how the yellow part here on top directly tells you about what the product is and the solvent, which is here and everything. So as of my mechanism, it shows everything step by step on how I got to the final product, which is here in the bottom, which is showing here number one. Um, and indicates all about the experiment that we did with the article, that it shows and provides all this information and how the mechanism is a better understanding on how we got into the product. So for authors, these are the authors which um, were the ones who, provided, helped with everything with the experiment, also helped with the checkpoints and everything. So we also have, if I'm saying this correct, Matthew Andre Marine, which was raised in Canada, province of New Jersey. After his BS from University of Ohio, he went to get his PhD in Old Lewis acid chemistry, and he is interested in the mechanisms, investigations, and the development of synthesis methods. We have Samantha, who is from Canada, after finishing her BS at the University of at the University of Otoya, if she's saying correctly. She traveled to Australia to serve as a visiting research with the Suriname group, and she also returned back to her university that she graduated in, and also, completed her MSc in photochemistry after learning how to handle hydrocarbons and move patch the process into the flow. So we have other authors here, as well as we also have all these other authors that also provided. Like the first one is Cecilia, which is from Australia, which she also graduated from Sydney. She also did her BS in Honduras. She relocated to the Australian National University in Canberra, where she is now doing postgraduate studies with with Professor Michael. She also did a research focusing on the synthesis of new um, carbons. We also have Michael, who studied in chemistry at the University and of Nottingham, if I'm saying that correctly, which he earned his PhD under John Murphy, and performed, a postdoctorate research with Lou Mander at the Australian National University of Canberra, which he worked as a Massey University in New Zealand and then the University of Sydney before joining the NAU Research School of Chemistry in 2002. We also have another author named Alexander. He received his MSc in 2016 from the University of Vienna, where he worked at and palladium and gold catalyst. He is a PhD student in Pro Neuromandarin Lab, and where his doctorate research focuses on carbonation chemistry and what was the other one? Asymmetric palladium catalyst and total synthesis, which is another author that we also have, which is Martin Berger. Berger? Be- you know, is originally from Austria. After his MSc from the University of Wien, he also joined Professor Nguyen in his lab to finish his doctorate degree. He also focused on synthesis in natural products and using CH activations and development of novel synthesis. And that's it. Thank you so much, and I hope everyone enjoyed my PowerPoint.